going to finish the question. So we're on the m particle, and we're going to look at the F equals ma equations for this particle. So what way is this particle moving? Well, we know it's moving down in this direction, or up in this direction, with an acceleration a. We also know that the wedge itself is moving to the right with an acceleration b. So if we were to try and resolve this into components which are parallel and perpendicular to the plane, we would have b cos 30 here, and we'd have b sine 30 here, given that this angle will be 30 degrees. Because, you know, the wedge itself has this shape, so if that's 30 degrees, then if that's b, that's 30 degrees, so we're just splitting it into the two directions. So play around with that, because it does take a while to get your head around it, and it does take a while to get used to it. So don't be afraid to practice this question again and again and again. So let's do F equals ma for this direction first. We could split this into, you know, perpendicular and parallel to the plane. So the parallel to the plane first. Well, our forces in that direction, we think that the m particle is going to move up the plane. So for F4, it will be t minus mg sine 30, because these are the only forces in that direction. You have your t here and your mg sine 30 equals the mass, which is m. Now for acceleration, it's moving up the plane, so a is going to be our acceleration up the plane. But remember, we need to take into account that the wedge is moving towards it as well. So what we have to do is we have to take the two of these away. We have to take that acceleration b cos 30, sorry, the pen is acting a bit funny here, away also. Remember, our forces, we add or subtract forces because they're vectors, so these are the forces in that direction. For our accelerations, they're vectors as well. So if it's accelerating up the plane with an acceleration a, down the plane with an acceleration b cos 30, its overall acceleration will be a minus b. Well, this equation just becomes t minus mg over 2 equals ma minus m, or root 3 mb over 2. And that is equation 5. A lot of equations in this, you don't need them all for the answer, it's good practice to do them all. So that's the acceleration or that's the F equals ma equation in that direction. Let's look at the F equals ma equation in the direction which is perpendicular to the plane. So now we're looking at these forces, our R2 and our mg cos 30. Now in this case, the plane is actually moving into it. Because the wedge is moving to the right, this plane is moving into this. So what we're going to assume is, we're going to assume that the R2 vector is going to be bigger. So we'll say our F4 is R2 minus mg cos 30, because the R2 is bigger, because the wedge is moving to the right, equals its mass, which is m, times the acceleration, and there's only one acceleration in this direction, which is b sine 30. So that will just be b sine 30. This then can become R2 minus root 3 mg over 2 equals mb over 2. So that's going to be equation 6. So really, this is the important bit. The last bit of the question, I don't want you to worry about too much now. Obviously look at it, but trying to get all those equations, because that's where most of the marks come from in these questions. Now the question was to find the acceleration of the wedge, so in other words to find b. We've done all of these equations, and pretty much you get most of the marks for that, but now we have to somehow use these equations to get b. So when I look at it, this equation has b in it anyway, and it has r1 and r2. This equation has an a and a b and a t, so there's lots of variables in that one. This one just has a b and an r1. This one has lots of variables again, and this one just has a b and an r2. So I'm going to use equation 1, 4, and 6. And what I'm going to do is I'm going to rearrange equation 4 to give me, well, r1 equals root 3 mg minus mb. And then I'm going to look at equation 6 to give me r2 equals mb over 2 plus root 3 mg over 2. And it makes it look like I've done this really quick, but obviously I've thought this through already. And what I'm going to do is I'm going to sub in those into equation 1. Sub into equation 1. Sorry, there's something going wrong with the pen here. That's why the writing's getting even messier. So when we sub that into equation 1 becomes root 3 mg minus mb over 2 minus root 3 mg over 2, that's an m, that's a 2, equals 8 mb. And hopefully you can see where that's come from. That was originally r1, all this bit, minus r2, all this bit, equals 8 mb. Solving that then, we're going to get root 3 mg over 2, pen has gone to the dogs, minus 3 mb over 2 equals 8 mb. That's going to be root 3 mg minus 3 mb equals 16 mb. We've minus 3 mb here, 16 mb here, so we can bring that across. Root 3 mg equals 19 mb. M's cancel, and we're looking for b. b equals root 3 g over 19. And that's your answer. Meters per second squared is your unit.